Thanks. Kalispera, Ifilimu. Correct? Amazing. Thanks to be here for this talk. I'm used to say that in conference there are no good slots. The last slot is especially bad. So I will try to be entertaining so you can go to the after party with a lot of energy. I'm Nicolas Frankel. I've been a developer, an architect, whatever. Like I've worked in projects in different technical positions, and since a couple of years, I'm a developer advocate. As you can see from my hair, I'm old. I've experience. And so when I was young, we were talking about monitoring. And monitoring was a bunch of people sitting in front of computers and a big screen of big wall of screens, and they were watching dashboards all day long. And if something happened, then they will start to try to fix the situation. That's what we called alerting at the time, like a bunch of monkey people doing not great. It's not possible anymore anyway because our systems are becoming more and more distributed. You notice that I avoided the M word, no? the microservices word. Most of the time, we are not doing microservices. We are doing like big distributed ball of mods. But even if you don't do microservices, your information system is more and more distributed. So we had to come up with this new idea of observability. Because I'm super lazy, I generally use definitions for Wikipedia. This one is not that bad and mentions logging and tracing. But actually, it forgets one of the pillars. There are three pillars in observability. Metrics, like the people watching the monitors, logging and tracing. He was trying to be quiet, right? Like a ninja, he came in the dark, but I saw him. The talk is mostly about distributed tracing, but I still have one slide about metrics and a couple about logging because I still think it deserves some comments. Metrics, every company does them. I hope you do. Who doesn't do metrics at all? Yeah, everybody is too afraid to raise their hand. That's fine. What I advise you is you already have the infrastructure, but what you can is provide higher level metrics, metrics that are closer to the business, because to be honest, nobody cares about like the percentage of used disks in the business. They care more about the number of orders or perhaps the number of like 500 errors per second. So that's what you should provide, and since you have the infrastructure, it should be pretty straightforward. Logging is much more interesting. The first thing is what to log. When I was young, when I was inexperienced, I thought I was very smart. Now I learned. And I was a JVM engineer. And I thought, logging is pretty boring. We have to do that every time. And even though I'm a good developer, I'm a good engineer, I'm trying to log very nicely to make the life of ops people easier, I noticed that some people in my team, they are not that good. They don't care about logging, or they log the wrong stuff. I will be smart. I will write a Java agent that will actually log every input parameter or every method and log the return value. And so when we go to the server, when we actually read the file, then we will see everything, and people will praise me till the end of my days because I'm so smart. And then I understood that it's not a great idea because sometimes you don't want to log the input parameters, such as the passwords, for example. You don't want to log the passwords. It's a bad idea. So it's back to square one. You actually need to take care to log. Francesco has been telling us about the code review, and Paco has been telling us about the code review, and well, you need also to take care of the logging statements. When you do a code review, you need to take care that the logs are properly implemented. So there is no other way to do it but manually, and it's boring, but you need to do that. Likewise, when I mentioned that in the past, when something happened, you actually logged into the machine that produced the log. because there was an error, and then the sysadmin or perhaps the dev, if they had access to the log file, they could actually read the log, and that was amazing. But the thing is, again, our system being more inbound distributed, which machine do you log to know where the bug is? You have no clue. Worse, the machine that produced the logs might have been gone because we are using containers. So there is no other way than to have a centralized logging system. And so now you don't actually log in the machine, you log to the centralized logging system that actually has all the logs already indexed. It means that you produce an unstructured log on the machine, and then you push or you pull or whatever, and then there is a grokking phase where you actually parse the unstructured into something structured, and then it's indexed into the centralized logging system. Why don't we just get through by producing structured logs which can be directly indexed? Because this central component that actually does the grokking, like parsing the unstructured data into structured data, it takes time, it's fragile, and it brings nothing. So if you can, just produce JSON already. When I was a young engineer, I was told never, ever to log to the console. Everything had to be written in files so that could be rotated and archived and whatever. Now we are using containers, no files anymore. Where do we log? The console. So it just changes all the time. I mentioned whether you push or you pull, or you have an agent that's grab and push. There are different architectural choices. It depends a lot on your context. I mentioned parsing the log. You shouldn't parse the log. It's an additional step. Just produce the log structured. Then you need to think about storing the log, and because sometimes it might cost money. So also purging the log, searching the logs, displaying the log, blah, blah, blah. So you have a lot of things to think about. Here are a couple of centralized logging systems. I'm familiar with Elasticsearch, but choose your own poison. Now comes tracing, which is, in my opinion, the most misunderstood or even not done pillar of observability at all, which is a shame because it's very, very, very important. I don't like this definition either, so I came up with my own, and probably it was inspired by a lot of others. The idea is you want to trace a business request across several components of your information system, and distributed tracing gives you a set of tools to achieve that. If you have done observability and traceability before, you might have used Zipkin or Jaeger or OpenTelemetry. The problem is all of those products, they were actually proprietary. Even OpenTelemetry was open source, but basically every one of them had their own way to do tracing. And the problem is that now you are an architect and you are using, let's say, Jaeger, and you need to choose a library, then you are restricted by libraries that are supported by Jaeger or that support Jaeger, which is not great because it has nothing to do with the best value you can get or whatever. It's just, hey, you have an additional requirements. So when you have this kind of context, probably you need a standard. And when I say a standard, I'm not telling about the XKCD comics where there are 14 competing standards, and you say, I will get a standard to unite them all, and now you have 15 standards. I mean, a real standard, something that really, really works. For that, you need a strong governing body. And I think the W3C is this body. So they decided to write a specification, which is actually quite concise, called the Trace Context Specification. Anybody has read it? A couple of people. Great. It's quite easy to read, right? It's not black magic. It's, in my opinion, quite simple. It all bases itself on HTTP header. And in this HTTP header, you can find some basic concepts. The first is the trace. The trace is one single request that flows across all the components of your software. And the span. And the span is something that happens inside one of the components. All the spans, they are attached to a trace, obviously. And a span can have children. A span can have multiple children, but it can only have one parent. So from like in a visual display, this is a single trace that grows across X, Y, and Z. And then you can see the unit of work inside each of the components. And Z and Y have for parent X. Now you can see they are executed in parallel. And X has no parent. It's the first span. Looks easy, right? It's not high engineering. Now, how do you do that? Well, you can actually write your own code to produce the HTTP header, the trace parent, and then you can write code to extract it and to propagate it. But we are a lazy bunch, which is good. So why not have somebody do that for us? And comes OpenTelemetry. OpenTelemetry is bigger than the trace context because it's not only about tracing, it's also about metrics and logging. But again, I will restrict myself only to tracing. And it implements the W3C trace context. So basically, you don't need to write everything yourself. In most technologies, in most stacks, you will find a library, a framework, whatever that supports it and does it for you. Worth mentioning is that the merge of open tracing or open census, because it's very rare that two open source projects merge successfully. And now it's a CNCF project. It has a lot of users. Probably there are more followers now than when I wrote this slide. You can think about OpenTelemetry like the black hole of, well, ops or DevOps, depending if you want to be looking like a weirdo or just somebody who used the word DevOps for no reason. But basically, it's used across the industry now. And if you produce a library, a framework, or whatever, there is a huge chance that you will need to support OpenTelemetry. The architecture is quite straightforward. You have like sources of OpenTelemetry data, and what OpenTelemetry defines is how you send data to something called a collector. So it defines the format and the protocol, and that's all. The hotel collector itself, so OpenTelemetry provides something called an hotel collector, but this hotel collector is just for convenience. It doesn't store anything. It's just made for you to like aggregate or transform or filter out or enrich or whatever. But you need to have an Intel collector that actually stores your data in the end. And as soon as something is compatible, OpenTelemetry compatible, then it's an hotel collector. And then you can have one hotel collector in front and it forwards it to the other one. Jaeger and Zipkin are now OpenTelemetry compatible, which means that if you're already using one of them, you can just open the right port or configure them to accept OpenTelemetry data. You don't touch your infrastructure. And then you change the way that you are sending data from their proprietary protocol to OpenTelemetry. And you're done. And now you are using OpenTelemetry, and you can use any framework, library, or whatever that is OpenTelemetry compatible. Icing on the cake, now, if you want to change your infrastructure, you can replace Jaeger by Zipkin or by anything that is OpenTelemetry compatible, because it's OpenTelemetry. So far, I've talked a lot about like more general stuff. Now I want to talk to you as developers. Who here is a developer? Yes. DevOps, whatever that means. Ops, manager. They are ops manager. That's good. So this talk is mostly focused on developers, how they can help their ops colleagues. As a dev, you have two main ways to get OpenTelemetry in your app. The first one, the one that I would advise you to use at the beginning, is auto instrumentation. There is one requirement: your tech stack must have a runtime. For example, who here is a JVM developer? There is a runtime. Python, runtime. Node.js, runtime. Go. There is a language that most people are using, which I don't know here. What are you using? Python and Go. Okay. So I have that in my demo. If you have a runtime, you put the instrumentation, the automated instrumentation. For example, on the JVM, you have a Java agent. On Python, you have this kind of like instrumentation at runtime as well, Node.js as well. Basically, you don't let your developers know that they will be using telemetry. It's just something that you do at runtime, and then it's fine. It's easy. It doesn't cost you anything. You can actually put an OpenTelemetry collector in a dark corner doing shadow IT. Then you start to get data. Then when there is a bug, you use this to solve the problem. And then you can come to your manager saying, look, this is what we were doing under the cover, but it's very helpful. Now give us budget. That's the easy way. When you don't have a runtime, there is no other way than to do manual instrumentation. Once you have the budget, you can also customize the automated stuff. But it all depends. What I advise you again, low-hanging fruit, auto-instrumentation, don't bother yourself. Now I've talked a lot, and I have a demo. So I'm a developer advocate. We are the king of Hello Worlds demos. Here I try to have a not so like dumb example. I have something taken from an e-commerce shop. Of course, every component is very simplified, but the architecture looks like something that you can find in the wild if you are doing like e-commerce, microservices, or whatever you want to call it. So the context is you load the homepage of the e-commerce shop. You ask for a couple of products. Each product calls for pricing and for a stock, and that's it. So, of course, at the front, I have an API gateway. It forwards the request to a Spring Boot Kotlin application. I will be using the Java agent to instrument it. Then for the stock, I have this inventory, and the inventory calls an internal API gateway that calls different warehouses. So I have one also in Kotlin and Spring Boot, but this one I am using GraalVM native, so I can't use a Java agent. I'm using Go. I hate Go, but it seems to be very popular, so I added a Go microservice. I added a Ruby and Sinatra just for fun. For the pricing, I have a Flask app. Everything uses, I didn't put it on the diagram because it was already full, uses a single database with a different schema for every component. I wanted to see how it works with caching, so I have a Redis instance that caches the price. And because I was asked lots and lots of time, hey, how does it work with asynchronous messaging? Because you told about HTTP header, and we don't have HTTP header in asynchronous messaging, whether with MQ or Kafka. Then I've added one, and I do everything manually. So when the catalog is requested, I publish like dummy analytics in MQTTQ. And then there is a Node.js app that subscribes to it, and you can see what happens. So depending on what technology you want me to describe more, I can do it. But now, for the moment, I will just start Docker Compose. So I will just make sure that everything is down. Okay, and I can up it, and I can show it. I can describe the Docker Compose YAML file. So first, I have Jaeger. Why did I choose Jaeger? Because it's very easy to configure. I take the image, I have one environment variable, and up it opens up OpenTelemetry. So no other reason than it's very easy to use. I'm using API 6. This is the catalog. So this is Kotlin Spring Boot. And you can see that, yeah, it's Spring Boot. I have the pricing, Flask and Python, inventory in Rust. So I made it so that it can handle any number of warehouses. I have an internal API gateway just for fun. I have this Go stuff. Here I have the Kotlin Spring Boot, but with GraalVM, so with no agents. And this is the Ruby one, Postgres, Redis. Shall we start? So here, you don't care about the request itself. The result is not interesting, but what you care about is this. So here I'm using Jaeger. I can find the trace, and here I have it. So something really, really important is normally you would sample. Like if you've got 1 million requests, you don't want to have 1 million traces. But here it's a demo, so I have no sampling at all because I don't want to send 1 million requests to get one trace. And this is it. It's very small, so I'll try to make it bigger, but that's the problem now. It doesn't work as nicely. Okay, you need to come closer. Sorry, this is not made to be here. I will stop here. So you can see all the components that were in my schema where I told you this is it, this is it. Here you can see like they are in a sequence. So first come the API gateway, then the catalog, and here is a single trace, right? And here are the spans. And when you see the black stuff in the span, it means it's active. So basically the span here means that API 6 works from here to here until it gets, at the end, it gets the response back. Afterwards, it forwards it to the catalog. There are a couple of things happening inside the catalog. Here I have the find by ID. So who is interested in the Java stuff? Okay, I will show the Java stuff. I mentioned Java, it has a runtime. So if you look at it here, there is actually not a single dependency on OpenTelemetry. So no dependency, I can show you the codes, there will be no import about OpenTelemetry. So how does the magic work? Well, normally I mentioned you would do that at runtime, but here I'm using Docker containers, so I'm doing it at build time. And this is a multi-stage Docker file. Everybody is familiar with multi-stage, or should I explain? Who says I should explain? Okay, so the first step is I compile normally, then on the second stage, I use the artifact that I compile, and here comes the magic. I add the Java agent from GitHub, and when I run, the Java agent knows how to produce spans and to send those spans to OpenTelemetry. So this is the magic I told you about. You can do this without the developers knowing anything about OpenTelemetry. The default spans here, I get it when I actually receive a request. I get it here because I have a Spring Data JDBC stuff, so I need to find it because it must be here. I'm using coroutines. And I have this one because the driver also is instrumented, the Postgres driver. And I have it here because I make a request. So here I didn't like select anything. This is what the agent does by default. I have no choice. Who is interested in Python? Rust? What do I have? GraalVM native? More, okay. GraalVM native, I can't use agents. So in that case, I need to use the dependencies. So here I'm using micrometer tracing, which is the Spring Boot way to do tracing. By default, it uses Brave, so I need to use the bridge to OpenTelemetry, and I need to use the exporter for OpenTelemetry. So I need to actually use these dependencies, but because it's Spring Boot, on the code side, I don't need to do anything, right? I don't need to have any API call or annotation. I'm using the regular annotation, and it works like I want. And I'm very happy to have it. And this is the EU stuff, Stock Europe, here. So here, by default, I get when I receive a request and when I make a request. That's all. And since there were a couple of hands for Python, and I don't want to show you Go because I'm too bad at Go, and I will say bad stuff about Go. I hate Go. Here is the Python stuff. So again, nothing, no dependency because I'm using a regular runtime. And then when I'm doing the Docker file, then I add the dependency of OpenTelemetry itself. I install my dependency, my regular dependency. And here, this allows me to, well, it allows me to sniff all dependencies of my app, check if there is a dependency that is relevant for OpenTelemetry, and then install it on top. And because I was using, for example, Flask, then I automatically get this trace. And because I'm using a Postgres, the Postgres driver, the psicoc2, then I got this span when I connect. And again, this is all for free. Looks nice, right? So we can perhaps do a bit better. Imagine now we have the budget. Everything is on GitHub, so if you feel frustrated because I didn't describe your stack, then don't worry. You can check the GitHub and see what I did. Now I can do manual instrumentation by trying to do annotations. And this is fun because the Python stuff, I updated it this morning, so there is a chance it doesn't work. Who loves a demo which doesn't work? I mean, you like it like, now I'm not alone anymore. But I tried it multiple times. Or not. Pricing, sorry. No, it doesn't work. So I've lost the pricing for whatever reason. So I didn't do it good enough. What I changed is here. Now I have added the dependencies myself. So I have added this. Of course, now it doesn't work. So I need to fix it. But the idea is now you can create an additional function, a private function, and then you can add this trace here. And normally it should be doing something like the pricing should be here, but for whatever reason here doesn't seem to be part of the trace. On the catalog side, then I'm adding, sorry, not this one, I want to have the POM. I'm adding the annotations. Where are they? Here. And now I can add additional spans. So by default, you saw there was only the repository that was instrumented, but here I can say, oh, I want to have this method, which is instrumented, this method. By default, the name of the span is the unqualified name of the class. So just the name of the class without the package, plus the name of the function, but you can override it. So here I should have a product handler fetch, and if I say here, I have this fetch here. Something that I didn't mention, you can associate key value pairs. So by default, they are default values. So here, code function, fetch product details, code namespace, whatever. I didn't do anything. but you can also add them. So here I want to add the product ID, for example, because for whatever reason, I want to be sure that when I send, there is a bug, and I want to be sure that when I send a product ID Y, then the component receives the same product ID. So here I have changed my function signature. So I pass the product ID as part of product, but here, because it's annotations, I need to add an additional parameter and to annotate it. And now I have this product ID, which is free. And of course, if I redo the same stuff with 2, I expect to have 2. And now I have the pricing for whatever reason. So I have the pricing anyway. So that's what I told you. Here, I have the same, sorry, I need to go back a bit. Here, I have the name of the span, select star from prices where product ID equals something. And here, I have this name here. When I wanted to show you is when I do the fetch, now the product ID should be 2. But the annotations in Python, they are not enough to get me the product ID. So I need to use the complete API. Meanwhile, I also want to implement the asynchronous stuff. So I will change both at once. I will stop here. And I will go to master. And I will start again. And then I will use ID 1. What I change on the Python side is instead of using annotations, in Python it would be decorators, I use the full-fledged API. So here I keep the same structure of my code. Previously I changed the structure of my code to have decorators. Here I kept the same structure. And then with this full-fledged API, I can add attributes. So again, now imagine I have this bug, this stupid bug. I find the traces. I should, on the fetch, I should have product ID 1, yes. And on the Python side, I check that now I have product ID 1, yes. So if there is a bug, it's not because I'm sending mismatched product ID and receiving the wrong one. Which gives us how long I have, like 6 minutes. I will show you the asynchronous stuff. The asynchronous stuff is these analytics filters. So on the catalog side, I have added an additional analytics filter. So on my app, every time I do a request, I have this analytics filter here. The analytics filter will actually create a span with data. So of course I have data way to send the message, but when I create the payloads, what I'm doing is I will extract the HTTP header through the API and I reconstruct it. Because so far, we didn't touch the HTTP header. I mean, it was magical. We didn't know what actually happened. But here I'm extracting it and I create the same string as described in the spec. So in the spec, it says, this is the trace parent. It starts with 00 dash, then you have the trace ID dash, then you have the span ID dash, then you have some trace flags. And here you have two choices. Either you are using a message queue that allows metadata, which is the case here. For example, MQ TT v5 allows metadata. So I can pass it as a metadata to the message. So the message doesn't care. It will be some like outside component that can take care of this trace parent. Or you can't, then you need to pass it as the payload, and then, well, it's not as fun. The payload itself is the parse and the host address, but you don't care. And on the analytics side, this is Node.js, so I'm really bad at that. But basically, I have this on message. When I receive the message, I get the metadata out, and I extract into, so I extract the header, which is normal HTTP because it's metadata, and I recreate the active context out of it, and then I can create a span, like a manual span, because I'm using the full-fledged API. And here you can see that here I have this analytic stuff. So now my analytic component is part of my trace. And I have one single trace, even though I'm using asynchronous components. It can cause issues. Basically, it can cause the following issue: that imagine that I will stop the component, stop analytics, and I redo a request, let's say 2, and here I find the traces, and here we don't see the analytics anymore. Of course, it's down, right? And now if we start it again, what can happen? Well, it will read the data and contribute to the trace. And now we leave it a few seconds to do its magic. It has read the message, it has scanned the span, and now our analytics component is on one side and all the rest is on the other side. And because every span is basically milliseconds, and I've waited seconds, then they are very far away and they are like squished on each border. So it depends on if you want to have this kind of stuff. If you can filter out depending on the UI, you might say, I will have it and I can filter out this trace, so I have a regular trace. And if I want everything, I can have this kind of like display. And that's all what I wanted to show you, which is, I believe, already a lot. You can follow me on Twitter, even though I think it's dead. You can follow me on Mastodon. You can follow me on Blue Sky, because I don't know what the next thing will be. Perhaps it will be nothing. If you are interested about the codes, then everything is on GitHub, but it's hidden behind a bit.ly link, so I can check how many people are actually looking at it. And to be honest, this week I did the same talk in Nantes with about 800 people in the room. I saw one link opened, which is good. Like 1 out of 800 is not bad. And now I have 2 minutes and 15 seconds for questions. Yes, there is already one question.
Cool. Okay.
What's the status for OpenTelemetry for PHP, if you know?
I don't know. But what I know is the site is really, really well done. Last time I checked, there was an entry for PHP, so I think it's fully supported. But because I didn't want to learn PHP to add an additional warehouse, I am accepting pull requests, by the way. So if you want to have a warehouse with PHP, I can add one more stuff and have it in the demo. I think it's fully supported, but again, I can't guarantee anything, and I'm an engineer, so if I can't guarantee, I prefer to say I don't know. Other questions?
Cool. Other questions? We do have time, so it's the last talk of the day. Everyone is tired, you know, waiting for food.
Everybody wants their beer. The gentleman here had a question.
Yeah. Just a quick question, if you have any consideration about enabling tracing in production. Maybe enabling tracing in production systems, maybe what about the load that is produced by tracing, how it's handled?
Okay, I have this question about performance at every conference. Every time I do this talk is, what's the performance impact? And my usual answer is, well, what is better? To go very, very fast without any inkling about what you are doing, or to be a bit slower and know exactly what is happening in your system? And the answer is, it depends on your context, right? So if you are interested about the load, then you should do your own like load testing in your own environments. Now, probably, as I mentioned, if you have a trace for every request, you will be in trouble very fast. You can do sampling. So at every component, you can like sample so that you don't get the full stuff. So for example, you can have like 10% at the beginning because you are not sure, and at the beginning, well, you have space, you have storage, and you want to be sure. And then you can like decrease the sampling and because you've got more confidence, and then you deploy a new component that requires like a bit more confidence, then you can increase it again. So even the sampling rate is not one single one, it happens at every step, and it can be dynamic in time.
So it can be enabled and even configured during runtime, the tracing behavior.
Well, it depends. Here I'm on Docker Compose, so basically no, but depending on like what platform you are using, then you can probably change the variable and it will adapt itself, hopefully. You need to check the library at the beginning. The most important one is the first one because it gives you the wide like filtering.
Do you know how it's used usually in production? I mean, most people, what do they do?
No, I'm a developer advocate. I know nothing about production.
Okay. Yeah.
Sorry.
And the last comment, I think Jaeger is written in Go, right? Itself.
Oh, a lot of stuff is written in Go. It doesn't mean that it's a good language. Okay. I mean, WordPress is written in PHP, right? So.
Yeah, I was wondering maybe it's out of this presentation, just what's your biggest, let's say, disappointment about Golang?
Exception handling.
Ah, okay.
Sorry, error handling. You know this, like this, like, no, I mean, there is a dedicated, like, key for Go user, like, if is nil, blah, blah, blah. Yep. I can show it to you.
So it's not something relevant to tracing itself, right?
No, it's just that I don't like Go. The language is, yes, this.
Yeah, this is, okay.
This is not acceptable for a modern language, I'm sorry.
Okay, thanks.
Any other questions before we finish?
Not about Go, please. Then afterwards, okay. I will be blacklisted because I don't respect others' languages.
Okay.
Hello. I have a novice question, actually.
That's fine.
I have seen you add the agent, everything works like magic. I
yes.
guess there is an environment variable somewhere, some configuration to where to send the metrics to?
Yes, yes.
Yeah, the metrics, sorry, the traces.
Yeah.
Right. Okay, and the second thing is when you...
this was not a question, was it? Or
because you didn't show where...
So it's, okay, so the question is where do you configure that, right?
Yeah, where to send the traces.
So that's the strength of OpenTelemetry is basically if you are using an OpenTelemetry compatible library or framework, you have all the same across all technologies. So here, this is where you send it. And here I disable the metrics and the logs because I'm sending to Jaeger and Jaeger doesn't know about metrics nor logs. And here I can override the name. And here you see they are the exact same. And this is Spring Boot and this is Python. And this is Rust. And this is Go. So they are all the same across all tech stacks. The only thing that doesn't respect is here is the API gateway. So I have my specific configuration for OpenTelemetry for the API gateway. But for all the rest, it's the same.
I see. And a second question that I had is, let's say that for some reason Jaeger or any OpenTelemetry compatible server that we use is down. Does this have an impact on our system?
So the thing is, I didn't check, but I can bet that everything is asynchronous. So basically, probably you will have a thread that goes into timeout, and that's sad, but it happens.
I see.
But it depends how much value do you want out of it, right? You can send the traces to an OpenTelemetry collector that is clustered and blah, blah, blah. There where you filter out stuff, where you sample stuff, where you enrich stuff, and then send it to something. I mean, afterwards, it's about your context and architecture. How much money are you willing to give for which guarantee, right? So.
Yeah, I'm asking as a question to convince, let's say, the market or whoever is responsible to take this decision for the budget, of course. Okay, thank you very much.
Thanks.